fractions, you still have to get the common denominator. But what we're able to do is we're going to try to eliminate our denominators. Now, you've probably done some sort of this in the past when you had fractions within problems, 1 and 2 step equations. For example, one of the things you guys might have done before, if it was like x over 2 plus 5 equals 8, and let's say you wanted to get rid of the fraction, what could you multiply everything by to make it go away? 2. And what you're doing here is you're multiplying by the common denominator. If you multiply everything by 2, you'd have to distribute the 2 to each piece. What's 2 over 2?
1.
Fraction gone. What's 2 times 5?
10.
What's 2 times 8? And you made your lives easier. It's the same basic process, but with just fancier looking problems. What's that? So if I have x over 3, plus x over 4 equals 7 over 4, what would be the common denominator that I can multiply everything by to get rid of the fractions? 12. Excellent. So if I multiply everything by 12, here's what happens. In long form, I'm multiplying it by 12. I'm going to show you guys a shortcut here in a second, but I want to show you what exactly is happening before the shortcut. You're going to get 12x over 3 plus 12x over 4 equals 12 times 7 over 4. What you are doing here is that you're creating some values that you're going to be able to simplify. Okay? What's 12 over 3?
4.
What's 12 over 4?
3.
And then what's 12 over 4 again? What we're doing here is the same idea. If I had to get a common denominator to make it 12, well, to multiply this one to get it to 12, you have to multiply it by 4. Multiply to get to 12, you have to get 3. It's the little shortcuts you'll pick up on over time here. All right? So you get 7x is 21, x is
2. 3. I felt confident. Right.
Okay. It's the same idea of what is this fraction missing. This denominator was missing a 4, so I multiplied it by 4. This denominator was missing a 3, so I multiplied it by a 3. This one was missing a 3, I multiplied it by 3. It's the same process. Okay? It's the same exact process. Right on. Why are you over there?
It's the same. No one has the same pose. More refreshment.
But she didn't like my singing, so but can you sing? But I'm still allowed to sing.
So you have x over 3 minus x plus 2 over 5 equals 2. What are you going to multiply everything by to get rid of the fraction?
15.
15, very good. So if you multiply everything by 15, first fraction just needs to be multiplied by 5. Because isn't 15 over 3 5?
Whoa.
You could go with that.
That's what I'm doing. Otherwise, it's just an extra step. If you want to write it out, the intermediate step, by all means, go for it. Okay? Because then it's just an extra simplified step. What are you going to forget to do?
Multiply the
FOIL. What's that? The negative to the 2. That's what I was talking about. You're going to forget the negative to the 2 here. So you have 5x minus 3x minus 6 is 30. What could you do to make sure that your answers are always right?
Put it back in.
Check it and substitute back in, okay? It only takes a second. Even though the sound of it is something quite atrocious.
I know that.
No, she's got a cool shirt.
One right now.
Sorry.
Oh, which mine? Six. I was like, something's not adding up.
Okay. That's too easy. I assume we have variables.
Please.
One thing I want you guys to remember is when you see a negative value, what you can do is just float the negative to the numerator. That's normally where people will place it. The book, for some reason, usually puts it on par with the fraction bar. It can go either place. Either there. You're there everywhere. I will not eat them in a boat. Why did they eat with the goats?
Oh,
We got a follow
straight fire.
See what happens when I feel better? I'm firing on all cylinders. There we go.
You ruined it.
That's 10.
No, it's what you do.
Firing on all cylinders. Okay, there's these things called automobiles. They have other things called engines. Inside the engines, there are things called cylinders. The cylinders move up and down on a crankshaft.
The cylinder's not moving up. The piston.
Excuse me,
Yeah,
pardon me. The piston, which rides within the cylinder, moves up and down, and up top there's these little valves for gases and air and fire and fuel and ignite, and it goes
This is something to
nice and go
know.
back and forth. Because if all the cylinders are moving,
Piston.
you are all, thank you, all the pistons are moving within the cylinders.
Are you saying you're like speed?
Yes,
They
I'm
take a-
just moving.
Skill.
He's moving with full force.
Anyway, what's the common denominator going to be here, guys?
He's on a
2x. Multiply everything by 2x. I'm going to go a long way here again one more time with variables, just to show you guys what happens when you have long form variable. Distribute your 2x to everything. You're going to get 2x times 4 over x plus 2x times 5 over 2 equals 2x times the negative 11 over x. And then, like I said, I'm showing you the long way first, and by all means, you can go back and do the quick substitutions, or not substitutions, the quicker way of doing it if you'd like, not a big deal. What's going to drop out in the first fraction? The x's go, so you get 8. What goes away in the next one?
2.
The 2's go away, and I get 5x. And then the last one, what does it go? What goes away? Now, this is the reason that I can simplify these things out, because each one of these numerators is its own monomial. Monomial divided by a monomial means you can simplify things out. There's no addition within each of those individual fractions. That's why this works. So subtract 8. Okay. What? It is, yes. Thank you for checking.
Double check.
Let's try another.
Okay.
Oh,
Like I said, it was simple.
let's not that.
You do this one. I've done enough. Let's see how we did. What's your common denominator be?
X minus 2.
All right, so you send everything by x minus 2. What's the only fraction that needs the x minus 2?
The 7.
The 7, good. So you get 5x equals 7 times the quantity x minus 2
That's where I went wrong.
plus
That
10.
was a prepared.
So you get 5x is 7x minus 14 plus 10. 4 equals 2x. X is 2.
Yes.
Yeah.
Wait, what?
Wait.
That's right.
Oh, no, it's
I got it right. I don't get the shortcut.
Now, take a look at that answer. Did that work?
No.
No.
Because
Wait.
I
did.
No solution.
Wait, you
No.
Come on.
Joke's on you guys.
Can you divide by 0 here?
Is that your question?
Yeah.
Aw.
You guys probably all got 2, right?
Yeah.
Okay.
No, I didn't get that.
I got negative.
I didn't get any of that. How did
So you get no solution because you can't divide by 0. What happens a lot of times with solving of the equations, you're going to get what's called an extraneous solution. An extraneous solution is an answer that's not an answer. Okay? It's
The answer's no.
it's a no solution style problem, but yet you have to go through to figure that out. This does happen. Okay?
So where's
Does it happen often?
Yeah, you never know. That's why I always tell you guys to go back and double check.
what's the cheat code?
That takes so much time.
Fine, then don't do it. If you don't want to do it, then check your answers. It's fine. You're just going to get them wrong. I don't care what you do on that point. But you have to check your work for a lot of these. Okay? For example, right away here, notice that I have values in variables in the denominator. Right away, what would my excluded values have to be? What can't x be? 1 and -1. Because on that secondary fraction here, I know that in the end, if I get x equal to 1 or -1, it won't work. Okay? So I look at how I'm going to get my common denominator. Here I have to factor something to start with. Not a hard one to work with. It's x plus 1, x minus 1. So what would be the common denominator between all three of those fractions? X plus 1, x minus 1. So what we have to do here is we're going to multiply everything by x plus 1, x minus 1. Now, would you like me to go long form when you're dealing with terms for the first time?
Yeah.
Sure.
Okay. What's that? So when we go, you know,
Why is it x plus 1 and x minus
because this one had the x plus 1 and an x minus 1,
1? Okay.
and this one's just a 1. So they did have the x plus 1s in common here, but then they had a 1, so you have to use them all.
Okay.
So I'm going to go long form and write out all of my terms, and then you'll start to see what things are going to drop. We're going to get x plus 1, x minus 1, 4x plus 1, all over the x plus 1.
Whoa.
Hi! You sort of best. The next fraction would be 12, x plus 1, x minus 1, over x plus 1, x minus 1, equals 3, x plus 1, x minus 1, all over 1. Oh, sorry, that's a plus sign there. Okay?
Dropping with it.
And now you'll notice terms will drop. Each one of those fractions should have something possibly that'll simplify out. In the first one, we have the plus 1s go away. In the second one, we have plus 1 minus 1 go away. But in the third one, we have nothing. Okay. So now we have to distribute out, FOIL out, and we're going to get 4x squared plus x minus 4x gives me minus 3x, and then it's minus 1. On the other side, we get 12 plus, what was x plus 1, x minus 1 equal to?
X squared minus 1.
So I'm going to just distribute that, so I get 3x squared minus 3. Okay. Now you just want to set one side equal to 0. Which side do you think would be easier to set equal to 0, the left or the right? The right, because you look at who has the highest power. Well, the highest power is the x squared, and which one of those is bigger, a 4 or a 3? The 4. So we're going to move everything to the left. So I'm going to subtract the 3x squared. 12 minus 3 is 9, so we'll subtract 9 here as well. So I get x squared minus 3x, what is that, minus 10 equals 0. What times what is negative 10 that you add together to get negative 3? Negative 5 and 2. Negative 5 and 2.
Because you took 3 from 12.
Which gives me zeros at
5
5 and negative 2. And then I would just have to double check to make sure they both work. What's that? This was 3x squared plus a 9 then, when I combined those two, for 12 and 3. So I have two possible solutions to double check. How's it going, Gavin? Maybe.
Wait, so how would you write out your final answer?
5 and 2. Those are my x would equal 5 and 2. But then I have to double check to see if either one of them is extraneous.
Oh,
Okay?
I got it.
So I would go back to my calculator. And we would have 4 times 2 plus 1 over 2 plus 1. I get 3 on that side, and I check the other side. 12 divided by 2 squared minus 1.
Isn't it -2? It's not.
Oh, did I write? Thank you. Sorry, so that my stuff's all wrong. So if I just let's redo that. So I have 4 times -2 plus 1. I get -7. -7 divided by -1 is 7. And then I check on the other side. I get 12 divided by 2 squared. 12 divided by 3, I guess 7 equals 7, so the -2 works. Are we okay on that?
Okay, yep.
Check it with 5. 4 times 5 is 20. 21 over 6. And then 12 divided by 24 plus 3 is 3.5. And what was the other one you did? Is also 3.5. So they both work. So sometimes when you get to an answer where you have 2 solutions, one of them might work, 2 of them might work, or it's possible both of them don't work. You always double check.
Just like a sheet of paper has questions on it. Something like this.
This, believe it or not, is the easiest one we have.
This is the easiest.
It is, because what would you do if you had this? You cross multiply, right? Because isn't that fraction equal fraction? There's nothing else tacked on there, right? So whenever you have fraction equal fraction, you just cross multiply. Okay. This case here, it's the same idea. Same basic principle. We have fraction equal fraction, so I get 2 times x minus 1 equals 1 times x squared minus x. Set aside equal to 0, and what should you get? Well, subtract 2x, add 2. I get 0 is x squared minus 3x plus 2.
Why is it plus?
Understand them all. 2 negative 1. Very good. So I have x minus 2 and x minus 1 gives me zeros at 2, 1. Now take a look at our answers up here. Can x be 2?
No, I mean, yes.
Yeah.
2 would work. Can x be 1?
No.
No. 1 would be an extraneous solution because I can't divide by 0. So the only one I really need to double check is to see if 2 works. So 2 times 1 is 2. 2 squared minus 2 is
It works.
2. And it works. Hallelujah. That's like Christmassy.
I watched National Lampoon's Christmas Vacation last night.
I heard that was on last night. I forgot to watch it.
So funny.
Christmas
That
story.
and Elf is on probably every night.
Yeah, we watched Elf with the kids last night. The kids love that movie. It's so fun.
I love
I
that.
love that
It is
movie. I just
really,
don't
really good.
have family goals.
The best way to spread Christmas
Okay.
cheer is sitting loud.
Questions?
There's no singing, let's go.
Do another one.
Yeah, there is.
Where they are. Those are my favorite. Are you going to sit once? So you actually get up on time? I don't know, because we don't leave it
I
up.
don't know what you usually say about me. I'll be really happy actually. I'm gonna go spend my day doing whatever I want.
All of them roll very well.
And then it's like 5-story building. It was fun.
All right, cross multiply in this case, again, fraction equal fraction. So you have 6 times quantity x minus 2 equals x minus 2 times x minus 1. Now, how many of you guys multiplied everything out? Okay, there's no point, because do this.
Oh, you know what? I did.
Makes
Got
me
me.
feel bad.
Got me.
I wouldn't have figured that out, so.
I did it the long way.
Still got the
Because-
right answer. I would not.
I got x equals 7, and I got x equals 2, and then I
It's only
wrote
two.
Huh?
That's poo-poo, Kevin don't like it.
Negative 2 works?
Yeah.
No,
No, it
2
doesn't.
works. Ah, you're right. 2 does work because 0 does equal 0. Now, here's the reason why when you do this, what happens is if this, when we get onto like graph-wise later on, this eventually, like next year, would create a hole in a graph where you have something that does work that can simplify itself out. So when you go the long way, okay, so you had x squared minus 3x plus 2 is 6x minus 12. Move things around. X minus 9, x squared minus 9 plus 14.
Yep.
X minus 7, x minus 2, so you have 7 and 2, and yeah. So if you do it this way, you're only half right. The reason I did it is because sometimes you guys actually see those things, but yet you eliminate a possible value. There are shortcuts, don't take them all, because here we got rid of a value that would work. It's not an excluded value. It'd be cool if it was the denominator. If they had common denominators of x minus 2, it would be okay. Yes, ma'am.
So like, to get the other 0, if you would have done it in the shortcut there, would you just have said like super times 2
Yeah, because they're the same ones on the top, and that's why that works.
So like, it with the different
Yeah. It's 0 and 0 on the top.
Let's go on, let's go
It
on.
was the same. I
I
know,
was-
but then it's 2 minus 1.
Let's see. In section 9.6, I just had the page number and I forgot it. Let's do these.
Does it make sense?
This starts on 571.
That's all I just Okay.
Okay?
I guess.
It's a good mix. Some no solutions, some with 2 solutions, some with 1 of those.
Oh, yeah.
Understand the stuff we did.
I was